Assalamualaikum and hi everyone. Alright, today we will discuss about 6.3, chapter 6.3, Le Chateliers principle. So these are the things that you should able to know. First, state Le Chatelier principle. Okay, so which means it's referring to the definition. Right. Next, explain the effect of the following factors on a system at equilibrium using Le Chatelier principle. So in terms of concentration of reacting species, pressure and volume, so including the addition of inert gas at constant pressure and at constant volume. Alright, temperature and catalyst. Okay. Right, so these are the keywords that you should know. Okay, now we move to the definition of Le Chatelier's principle. Okay, when a system is disturbed, it retains equilibrium, okay, by undergoing a net reaction to reduce, okay, the effect of the disturbance. Okay, so meaning that the system is already achieved equilibrium. So then the system is disturbed by a disturbance. Hence, therefore, the system is not at equilibrium anymore and it's trying to reduce the effect. Right, so there are four common factors that is referred to the concentration, pressure. Okay, so pressure here caused by changing in volume. Okay, change in temperature and also catalyst. Alright, so change in concentration. Right, so if the concentration of disturbance increases or decrease, the system react to consume some of it. Okay, so the position of the equilibrium will shift to the left or to the right side. Okay, in order to achieve a new equilibrium. Okay, right. So for example, like this. Okay, the system is already achieved equilibrium, right? Where Q is equals to K, right? Then more NH3 are added, okay, into the system. Okay, what would happen next? So therefore, the concentration of NH3 will increase, and therefore this will affect the Q is not equals to K, which means the system is not at equilibrium anymore. Right, so how to reduce the disturbance? So we have to reduce the concentration of NH3. Okay, so therefore the equilibrium position, it will proceed to the left. Okay, until Q is equals to K. So meaning that it will NH3 gas decompose to form more nitrogen gas and hydrogen gas. Okay, until the system reach the new equilibrium where Q is equals to K. Alright. Okay, next. So for example, like in form of graph. So we take a look in form of graph here. So we can see that the system at the original equilibrium. So we can see a constant line here shows that the system is already achieved equilibrium. And then we add more NH3. So the concentration of NH3 will increase drastically. Okay, up here. Okay, and the system try to achieve new equilibrium. So meaning that, so at this position, Q is equals to K. Okay, when we add more NH3, so the value of Q is not equals to K. Right, so the system try to achieve the new equilibrium. Right, so it will shift to the left in order to form more concentration of H2 and more concentration of N2 gas. Okay, and then when the concentration become constant, so the reactant and the product, so the value of Q would become equals to K. Alright, so keep in mind here the disturbance, okay, the effect caused by the addition of NH3 is reduced. Okay, meaning that the concentration of NH3 is reduced but not eliminated. So we can see that the line for the NH3 concentration, okay, remain constant here. Okay. Alright, so next. Alright, so the identify the disturbance first, okay, when predicting the equilibrium shift. Okay. Right, so we have 4 factors. Remember, concentration. So we already discussed temperature, pressure and volume, and catalyst. Okay. Right, so as a conclusion, right? So let's say I have this general equation. So increase the concentration of products. So meaning that either concentration C or concentration D. So the equilibrium will shift to the left. Okay. In order to produce more concentration A and more concentration B increase. Okay, as for the decrease in concentration of the products, either concentration of C or concentration of D, so the equilibrium will shift to the right in order to form more concentration of the products. Okay, right, next. So if we increase the concentration of reactant, either concentration A or concentration B, so the equilibrium position will shift to the right. Shift to the right. So therefore, the concentration of the products will increase. Okay. So next, decrease in concentration of reactant. Okay, for the reactant here, decrease. So the system will shift to the left, produce more concentration A and more concentration B. Okay, right. Okay, so let's say we have our exercise here. Okay. So to improve air quality and obtain a useful products, okay, sulfur is often removed from coal and natural gas by treating the fuel contaminating hydrogen sulfide with oxygen. So these are the equation here. Okay, what happened to the concentration of H2O if oxygen is added? Alright, so if the concentration of 2 is added, okay, so meaning that the concentration of O2 will increase. Alright, so the system will try to reduce the concentration of O2. Okay, but how? So it will shift to the right. Okay, so meaning that H2S react with oxygen, then it will produce more concentration. H2O will increase. Right, next, what will happen if H2S, concentration to H2S, if oxygen is added? Oxygen is added, right? So we know that when concentration of oxygen is increased, the system will shift to the right, and therefore the concentration of H2O will increase. However, concentration of H2S, which refer to the reactant, will decrease. Okay. Okay, next, oxygen. What happened to the concentration of oxygen if H2S is removed? Okay, when removed, meaning that the concentration of H2S will reduce. So the system will shift to the left. Okay, what will happen next? Concentration of H2S will increase as well as concentration of O2. Okay. However, concentration of H2O, which refer to the product, it will decrease. Okay. Right, next, H2S if sulfur is added. So meaning that more sulfur is added. What would happen to the concentration of H2S? Alright, so since we know that sulfur is solid, Okay, so sulfur here is solid state. So it does not effect on equilibrium. Okay, does not effect on equilibrium. Equilibrium position. Okay, so therefore concentration of H2S remain or unchanged.